ACT prep stuff.
Okay. Let me open up my ACT stuff. And I think we're under the McGraw-Hill.
Yeah.
And we went to page 453, number 37 last time. So let's look at 453 and see if there's a 38. Yeah, there does appear to be. 37 was regarding similar triangles.
Yeah.
Which is what almost all of my geometry students are working on now. All right, let's look at 38. It's a parallelogram with a right angle. Oh, hold on 1 second.
All right.
Okay. No, that's, hold on 1 minute and I'll get rid of him. I'm working right now. All right. My friend won't bother me again. Let's see. There's 2 ways you can do this problem. What are they?
You can, isn't it, you figure out that OPQ right triangle, like that third side, and then you just multiply 13 by whatever that third side is?
What's the third side? What is OP going to be equal to?
8.
Okay. Now, once you've figured out that third side, it's true, you can now figure out the area of the triangle. And what's going to be the area of this parallelogram? Do we know that's, yeah, that's a parallelogram. So what is it going to be?
Wouldn't it be 13 times 8, which is 104?
Correct. So you can add the 2. There's also a formula that to figure out the area of any trapezoid. This is a trapezoid. What's the area of a trapezoid?
Wouldn't it just be base times height?
Well, there's 2 different bases. When you have a trapezoid, you have the definition of a trapezoid is you have 2 bases that are opposite, parallel, and not equal. Because otherwise it would be called a parallelogram. And you have only 2 bases. And so the easy way to really remember the area of a trapezoid is it's the average base times the vertical height.
So it's base 1 plus base 2 divided by 2 times the height.
Times 8. So in this case, this base is 13 plus 6. This base is 13. So it's 13 plus 6, all that divided by 2 times 8, and then in one step you get the area of that trapezoid. Now, in all honesty, I can't recall ever seeing a question on the ACT that requires you to know the area of a trapezoid. In other words, every trapezoid question is kind of like this, where they turn it into a triangle and a parallelogram. And there's absolutely nothing wrong with doing it that way. I mean, you might argue that it's one step harder, but so I wouldn't worry about memorizing that formula for a trapezoid. But it is pretty easy to memorize.
Yeah.
And mean, if you think about it, is kind of a rectangle, only with two different bases. Okay, we have our trig question that looks like I cut the top of it off. So somewhere above there, it must say what is either the sine, the cosine, or the tangent of A. Well, let's do all three. What's the sine of A?
3/5.
What's the cosine of A?
4/5.
And the tangent of A?
3/4. Wait, yeah.
That's correct. Yeah. What is A? In that picture, if the question was, what is A, how do you get it?
Isn't it? Because it'd be sine of A equals to 3/5, and then
therefore, by definition, what is A equal to?
The inverse sine of 3/5.
Correct.
Okay.
They might actually ask something that difficult. Now, that would be on the upper limit of the trig you would need.
Because how high does the ACT go? Doesn't it just go to algebra 2?
No, it actually has exactly 4 trig questions on it.
Okay.
But they tend to be easy trig questions. In other words, if you know all your basic trig stuff, so katoa, like this question here, that would be your easiest trig question. But we will run into other trig questions. It's just they don't tend to be very hard. It's the trig you get before you actually take trig. So you've taken trig, so you've had much more trig than the minimal needed. Because the ACT is designed to be taken by somebody that's only gone through Algebra 2. Where, you get a very minimal amount of trig in Algebra 2 and geometry. Not anywhere near as much as you got this year, but you don't need that much. So you'll actually be at a bit of an advantage on the trig questions. You should be able to get all 4 trig questions. I'd be disappointed if you didn't get all 4 of them.
Yeah.
Okay, what's this?
So do they just want you to plug in x, like it'd be -3 plus m times 5 plus n?
Well, let's see what happens. I'm not really sure. I don't immediately see the way to solve this, but when that's the case, always do what you can do. So we have m minus 3 times n plus 5, right? Equals 0.
And the way I would think to do it is just make both of them equal 0.
Correct. So m, what are the solutions here?
It would be 3 and -5.
So now m plus n is
-2.
Yeah. Yep, that's what we had to do. That was a little different.
Is that the correct way to do it, or?
Yeah, I don't see any other way to do it. And that is absolutely correct, because once they give you this information and they tell you what x and x equal minus, well, hold on a moment. Let's go back and look at that.
Because, like, the way they're saying it, it kind of acts like it's...
Yeah. Okay, let's
like
examine
the 2 answers.
If these are the 2 solutions to this equation, then the 2 factors are x plus 3 times x minus 5, right? In other words, if I gave you that, you would tell me the two solutions are x is minus 3 and x is 5.
Yeah.
So this is a true statement. And this statement means that x has to be minus 3 or x has to be plus 5.
Because I just
Beginning to see the problem. I did this wrong, first of all. Well, no, hold on a second. No, let me think for a moment.
No, but like you flipped them, but actually no, you didn't. You did it right. But
no, I did
like,
flip them. I did flip them. I substituted 3 for x, and then I didn't write m. But that's because I tried to write it based on that first part of the sentence. In other words, if those were two solutions, then I can categorically say that this statement is true.
Yeah. I might just be overthinking.
No, I don't know. You might not be. Comparing this to this gives us what? If we have x plus m times x plus n equals 0. So I know this is true and I know that is true. Therefore, m has to be equal to 3 and n has to be equal to minus 5. M plus n is still minus 2.
Okay.
So yeah, I really, to be more precise here, I needed to write this one based on the first half of that sentence and then compare it to what they gave us to figure out what m and n had to be.
Nah.
I've always found the easiest way to do these is to just to wrap your mind around it, is to label the points. So there's a point, minus 2 comma minus 1. And there's a point, 2 comma 2. And they're saying that they are on a line and that x comma 5 is also on that line.
So do you find the slope of said line?
Yes. So because it looks like that goes through the origin,
Yeah.
but it doesn't have to, because notice I approximated everything here.
Yeah.
So in other words, that looks like a slope of 1, because if that indeed is the origin, then the slope is 1, and the point would have to be 5 comma 5. Right?
Yeah.
So, but let's just check, because I approximated it and didn't use graphing paper with a grid, I better check and make sure the slope is indeed 1. Well, what is this slope?
3/4.
Correct. So if the slope is 3/4, and there is some coordinate up there called x comma 5, how do I solve for x?
I mean, I'm kind of doing it the lazy way. I just went up 3 from 2, 4, or 2, 2.
That's actually the brilliant way to do it. I was doing it the hard way. Yeah, what I was going to say was that 5 minus 2 divided by x minus 2 had to be equal to 3/4. And now we can solve for x. But I actually love the way you did it. There's, first of all, nothing wrong with doing anything the lazy way when you're taking the ACT. Always remember that the goal here is not to prove how much math you know. The goal is to answer the question correctly in as quick an amount of time as possible.
Yeah. So up 3, which gets you to 5, the y-coordinate of 5, and then over 4, which gets you the x-coordinate of 6.
And that indeed would give you a slope of 3/4. So you're right, 6 is the answer. Wow, it would have been really easy to make a mistake on this after I drew my picture. For one thing, if I was really trying to go fast, I would have said, well, that's a slope of 1. I mean, I drew it right through the origin and it goes through 2, 2. You know, that looks like 1. But it's not. You have to actually figure out the slope. And in getting that, you did it the absolute fastest way. It's to go from this point. Okay, another example of one of their trig questions. How do we do this problem? This is almost a classical trig question. By that I mean they give you the trig function for one trig function and they ask you what the trig function is for another trig function. What's always the first step here?
I kind of just draw the triangle, yeah.
That's always the first step. Draw a right triangle and what else?
Label said triangle.
Well, I've got to label the angle that we're talking about.
Oh, okay.
Okay. Now I can dimension part of the triangle. What parts can I dimension?
You can dimension all of it. So the opposite of B is 8, and then the hypotenuse is 17, and the adjacent is 15.
Right, they didn't even make us do any trig here. In other words, we really didn't need this statement. We could have solved for the tangent of B based on just that. In other words, once I get 2 sides of this right triangle, I can always figure out the third side.
Yeah.
And once you got all 3 sides dimensioned, then you can figure out any trig function. You could answer what the secant of B was. But clearly the tangent of B is going to be 8/15.
Yeah. And when it's like that, I kind of just, because it's opposite over adjacent, and then sine is opposite over hypotenuse and cosines.
Yeah, the classic trig problem in your trig class is they give you this, and they tell you which quadrant it's in. And then they ask for what is the tangent of B. And that requires you to draw the triangle with only 2 dimensions, use the Pythagorean theorem to solve for the third dimension, figure out what the value is, and then put a plus or minus sign based on which quadrant it's in. But in a way they told you that here because they gave you a positive cosine and a positive sine. That's only one quadrant. That's first quadrant is the only way that they're both positive.
Yeah. Should I study some of the Pythagorean theorems before the test?
Okay.
Should I, or?
Well, it depends. I've never seen you lacking, but let me just give you some.
Or just to make sure, like, because I know 3, 4, 5, 5, 12, 13, 8, 15, 17.
What's X here? Oh, you're talking about the perfect Pythagorean triangle.
Yeah.
The only two that you really need to know are the 3, 4, 5 and the 5, 12, 13.
Okay.
You'll see maybe 5 or 6 of those on the test. And by that I mean those 2 or multiples. In other words, obviously on the test you might see a 30, 40, 50.
Yeah.
So, or a 6, 8, 10. We already saw a problem that had a 6, 8, 10 in it. But I don't think you need even the third largest one, which is what, 8, 15, 17 is the next one, is it not?
Yeah.
Yeah. And even on that one, notice that they didn't ask you to solve it. Even though it was the third perfect Pythagorean triangle, and you could have solved it without using math just by recognizing it. That just shows you that the ones they're looking for are the 3, 4, 5, and the 5, 12, 13.
Ah, okay.
How do you get x here quickly?
You just Pythagorean theorem and
Well, let's see you do it. In other words, there's going to be a lot of right triangles you got to solve.
yeah, so
There's the fast way and there's kind of the slow way.
I got square root of 13.
Okay, so what I try to tell people is whenever you're solving right triangles, where they've given you two of the sides, regardless of which two they give you, the answer always begins square root of. Start that with that, always. That way you won't forget it, because the most common mistake people make is forgetting the square root of. And then what goes on the inside, since I'm solving for one of the short sides, is the hypotenuse squared minus the other side squared. So what's that? 49 minus 36, square root of 13. Correct. All right. You seem to be pretty good on those. In other words, what I don't want you to have to do is go all the way back to this.
Yeah, I didn't go all the way back to like the basic. I just
it's a little, normally I like to teach students that memorize one formula and only one, and don't memorize manipulations of that formula. But this is kind of a special case. Only because you have to solve so many right triangles, it's actually worth memorizing that A is the square root of c squared minus b squared directly, or that c is the square root of a squared plus b squared.
yeah, that's where I went. I went to a squared.
Yeah, memorize both of those. And you don't need to memorize the third one, because the third one is just the other short side, which means it's b here and a there.
Yeah.
I think it's very much worthwhile to memorize these two and be able to apply them quickly, as opposed to having to solve that. Notice that if I have to solve that for a, there's a lot of work involved there. First of all, I got to subtract the b squared from both sides, and then I got to take the square root of both sides.
Yeah.
So memorizing these last two saves you some time, and you have to do it so much that it's really worth it to do it. Uh-oh. My hand was not very clear on this. Let's see if you can make this out. Which of the following expressions is illustrated in this picture? That coordinate is 0, 5, and that coordinate is minus 3, 0.
Yeah.
So tell me what your process is.
So it's pretty much, mine is just immediate cross out C and D because it's a positive. So just immediately cross that out, and then it's just y1 minus y2,
What's
which is
the
5
slope?
minus.
Yeah, that's always the thing. You almost always have to know slope in a problem like this. So let's automatically get slope. What is slope here?
Negative 5/3.
Does that look like a negative slope?
No, why did I get that?
Always do that check. In other words, always visually check to make sure. Because you took 0 minus 3 instead of 0 minus a minus 3, which is 0 plus 3. But the better check is to make sure your sign is correct by looking at it.
Yeah.
So which answer is it?
A. Non-common.
No, I can't read that either.
Form a straight angle, measure of one angle.
Let's
the other angle.
tell you what. Can you even read that? I can't read it.
Yeah.
Two rays of two adjacent angles form.
No, it's the non-common rays of two adjacent angles form a straight angle. The measure of one angle is twice the measure of the other angle was the measure of the other angle.
So they're talking about
A isosceles triangle?
In other words,
or no?
The two non-adjacent, that's what that word says?
Non-common.
The non-common rays of two adjacent angles. Well, we have two adjacent angles. The non-common rays are that one and that one, and they form a straight angle. So that picture appears to be correct. And the measure of one angle is twice the other. What's the measure of the small angle? So, what do we have?
Wouldn't it be?
Go ahead.
It would be 60 because 60 times 2 is 120. 120 plus 60 is 180.
Correct. And that's a perfectly fine way to get it. In other words, it sounds like you did a little bit of trial and error. Right?
Yeah.
In other words, you tried 60 and bingo, you hit it right on the button.
Yeah, because 45 doesn't sound right.
Right, and it's not going to work either. But really, the way to do this problem is to introduce a variable, x.
So it's x
is that angle. If that angle is twice, it's got to be 2x, and I can say that x plus 2x is equal to 180 because it forms a straight angle. 3x equals 180, x equals 60. It's the smaller angle. That's the answer. Now, the way you did it is, I love the way you did it. It's fastest. But if this was 5 times bigger instead of twice,
yeah,
it might be a little harder to do it that way, right? In other words, 5 times is not going to be as easy to pick a number out like 60 and see if it works really quick. So if the question was 5 times, this way is probably going to be the faster way, and then you get 6x equals 180, x must be 30.
Yeah.
All right. Number 45, we got 2 minutes. We can do 45. How many 3-letter orderings where no letter is repeated can be made using the letters of the word ponies? Aye.
Oh, I totally forgot how to do this one.
Yeah, I did too. Let's do this one next time. I'll have to look at this and think about it. I don't know if this is a straight combination problem. In other words, whether this is 6 chosen 3 at a time. It might be. I'm going to have to think about it. There's another formula for these. I think it's 6 chosen 3, which, I don't know. I'm not sure. We'll begin on 45 next time.
All right.
All right, Mitch? All right. Talk to you next Wednesday.
All right.
Okay. Have a good one. Bye-bye.
Bye.